Okay, time for the next presentation, Unlocking Java's Code Maze. Please give a big hand for Mihaela.
Hello. Can you hear me well? Yes. Perfect, thank you. Hello, everyone, and welcome to Unlocking Java's Code Maze session. I'm Mihaela. I'm a software architect at Systematic. It's a Danish company specialized in building software for critical domains, such as defense, which represents the business unit for which I'm currently working. But we also have healthcare, libraries and learnings, national security risks, and many others. I'm also a teacher at the Faculty of Cybernetics and Informatics in Bucharest, but that's enough about me. I bet you're curious about what it is about with this session, because the title sounds Unlocking Java's Code Maze. So what am I supposed to present to you today? And for this, I hope that you had a great break and you had some time to grab some coffees. Or those of you who attended the previous session, I hope you also had a little break, because we are about to kick off a session that is filled with plenty of Java challenges in the form of exercises. So I'll put you to work today. Think of Java programming as navigating through a vast, intricate maze, and I actually can show you an example of a maze. So think of Java programming as navigating through this maze, which can be vast, but it can be filled with both obstacles and hidden treasure in the same time. We are going to explore just a very small part of it today, but I do hope that we can energize ourselves with those exercises, and we can set the pace for uncovering some of its secrets and strategies. I thought of this session to be a blend of both exploration and active participation from your side, as I did mention. And the focus will be primarily on those exercises. And let me show you a couple of examples of what exactly we are about to showcase today. So we will handle some exercises involving collections. We have some streams exercises, records, concurrency, sealed classes, sealed interfaces, optionals, and many others. And now let me explain how exactly I organized this presentation. You will find here a QR code. Hope it's big enough for everyone to be seen behind the room as well. I will kindly invite you to scan this QR code and to register for the quiz. In case it doesn't work, even though I tested it 2 hours ago and it worked fine, as an alternative, I also pasted the slido.com link, and you have there the meeting number that you can join. It's 1695628. And while all of you will join, I will explain exactly how I structured the exercises. So first of all, for each of them, the same approach will be followed to ensure a smooth experience. So first of all, we will look at a specific piece of code. And there we will have one question. There are 2 types of exercises. Either what a specific piece of code do, so what is the displayed output if we were to run that program, or something a little bit subjective. There are some optimizations, some challenges in terms of improving that specific piece of code, either from a performance point of view or simply by improving its readability, for example. Those exercises, just a disclaimer over here, they are subjective because I thought of a couple of solutions. And out of those 4 solutions that I thought of, I selected one that I believe that stands correct compared to the others. But there are obviously several more ways to improve a specific code. So in case you want to debate a bit and discuss more alternatives to some of my exercises, we can discuss after the session on specific exercises. So, are you ready? Please raise your hand. Oh, perfect, thank you. In case it doesn't appear anything yet, is because I will need to trigger each of the questions manually. And I will now launch the quiz and show you the first exercise first. All right, so here we have just a warming up exercise. I hope the code is visible for everyone. I hope I zoom it right. It is OK? Perfect, thank you. So, a warming up exercise just to get used with the format. These examples deal with some static variable initialization, where the order of the initialization matters, because sometimes it can lead to unexpected results. With this specific piece of code, I'm not going to read it. I will let you do that. My question is, what is the displayed output? And I will now start the first question, and you have 20 seconds to submit your answer. For the other exercises that are a bit longer, obviously, I will give you more time. And afterwards, we will discuss which was the correct answer, which was not the correct answer, and why for each of them. And I think you have 5, 4, 3, 2, 1, and time's up. So let's see what was the correct answer. And prior to do that, let's investigate a bit your responses. So all of them were selected. Only one is correct. Perhaps I forgot to mention that. B was the mostly selected answer. That means 20. But 30% mentioned that perhaps we'll get a compilation error. If you don't trust me, I also can open my IntelliJ and we can run this code, because the right answer is B, 20. So those of you that selected this response, you're totally right. And let's see why. Why we don't get a compilation error? There isn't any compilation error. But probably you're thinking that we have a couple of reinitialization over there. What is important over here is that static blocks are executed in the order they appear. But the variable declaration overrides earlier assignments. So it won't throw a compilation or error. It will just override the earlier assignments. And we have there the first static block, which initializes value with 10. But the subsequent static declaration sets it to 20. Thus, the correct answer is 20. All right, let's go to the next exercise. Also in the area of warming up a bit. Once again, the answer is what is going to be displayed. We have a simple list of strings over there that perform some operations based on a stream obtained from that list. So what do you think we will get? OK. Most of you answered C, 50% actually. But also B and D were highly voted. So only A is definitely not correct from your point of view. But let's see which was the correct answer. And I believe that was way too fast, no? I should increase a bit the time. I will do that for the next question. Because the correct answer was actually D. And let's look a bit now on what the code was doing over there. So in this example, we are using the partitioning by, which should be already familiar because it's been in the Java API for a very long time, and if I remember correctly, it's been there from Java 8. And this partitioning by uses a custom method to determine if the string starts with a vowel. And there is a twist with that method because it uses regular expression. And the correct output shows words that starts with vowels. And that was why D was the correct answer over here. OK, let's increase the time so you have more time to explore this. And let's check the next exercise. And this is an example of code optimization. I did mention about them at the beginning. And here we have a list of strings as example. And their purpose will be to group words by their first letter. But what would you change to improve it over here? And for example, in this provided code, I use traditional for loops, but they definitely can be optimized. But the question is how? And among the answers, I read the answers now, and afterwards you will submit one of them. First one is to replace the traditional for loop with a parallel streams for better performance. Option B mentions to use a custom collector instead of grouping by collector for more flexibility. C mentions that we can encapsulate the logic within a Lambda expression to promote functional programming. Or D mentions that no changes are needed. Maybe the code is indeed optimal, and none of those answers could improve it from a certain perspective. And now, I will trigger the possibility for you to submit your answer. And let's see, what do you think? How would we change this code from those options that I provided? Or perhaps you will go with option D and keep it as it is. So let's evaluate a bit that code and see how can we improve it. All right, once again, we have all the answers selected, but the majority is for option A, which is the correct one. So great work. Most of you selected the proper answer. And now let's see why this was the correct answer and why the others weren't. You will still see the responses on the phone. I can switch back to the previous slide if needed. So the first option was to use parallel stream. Parallel streams utilizes multiple threads to process those elements concurrently, and this potentially will improve the performance. From the other options, we had to use a custom collector instead of grouping by, or encapsulate the logic within Lambda expressions to promote functional programming. Well, there are alternative approaches, but may not necessarily improve performance or neither readability in this context. And option D, well, as mentioned, it states no changes are needed, which is not the case here. All right, let's move to the next question. And that is, one second, for type erasure and generic. And let's check a bit what it does. It uses generics in this way. We have a box class, which is a generic class with a t-type parameter, and we have methods to set and get the content of that box. In the main method, we set the context first of all to hello, and then we have a raw box object, which is created and assigned the string box to it. So what do you think the display output will be in this case when we are going to run the code? And among the options, we have A, mentioning a hello, so that the string that we use to initialize the string box object. Second answer means 133, so the second part that we set for the raw box. Or we get an exception at line run box, raw box set content to 133, or perhaps we get an exception when we try to get the content from the string box. So out of these 4 options, what do you think we will get? And it's time for you to submit the answer. So let's see, what do you think in this case? We will get hello, 1, 2, 3, or an exception. And if you get an exception, where exactly? And I think we have just 5 more seconds. All right. And the right answer was D, and was selected by 5% of you. So let's see why. Type erasure in Java leads to row types that bypass compile time type checking. So assigning a row type to a generic variable allows setting content to different types. So when row box set content to 123 is called, so the second initialization that we have there, there is no compile time error. But when we try to retrieve by using the get content from that string box, there is the place where we'll get a class cast exception, because it is expecting a string, but it receives an integer. So this is the explanation behind this, this option, why D was the correct one. So we get a class cast exception when we try to get the content of that string box. All right, let's switch to the next question. Here we have something that I consider simple but funny, and I was inspired from something that I was doing with my students, because they didn't select it right, and I had to explain it several times. We have here an example of string concatenation. You know that Java supports string concatenation by using the plus operator, but the operator precedence is critical to be understood so that we can avoid unexpected results. And in this example, we have something like the result is +1 +2 multiplied by 3. And we simply try to display that result variable. Among the answers, so the result is that string is always the same for all 4 options. But the number that is being displayed on the right side is the one important. So we will get either 7, 16, 9, or 123. And let's see what do you think? So it's time for you to select one of these. OK? All of them are being selected. Let's see which one will be the winner. So we are in between either the result is 7 or the result is 16. The operation over there is 1 + 2 multiplied by 3. And time's up. We are in between 7 and 16. 9 and 133 got a few responses. So let's see which was the correct one. And the right one was 16. So most of you answered correctly. Well done. And now let's see why, so that the others that selected something else to also understand why this difference. So I did mention that when we use the plus operator, it means that we are doing a string concatenation. And that plus operator is used, when it is used with a string, it converts the other operands to strings. So in that expression, let's do a code breakdown over here. So we have the expression, the result is +1 + 2 multiplied by 3. When we evaluate this, we evaluate it from left to right. So first of all, we have the result is, which is a string. Then we have the plus. So when it is applied on a string, it converts the other operand to also a string. So 1 will be converted to a string. So we have the result is +1. But afterwards, we have a multiplication. And this takes precedence over the plus operator. So we will do 2 multiplied by 3. We'll get a 6. And the first expression from the left, the result is +1, plus the result from the multiplication operation will be converted into a string, and we will get the result is 16. So this is how the operator precedence rule works in this specific scenario. All right, hope you had some more fun with these numbers. And let's see what we have next. And let's switch a bit back to streams. And this example, we apply mapping to transform a nested collection, but it has a subtle condition within that mapping logic. I hope you can spot it. So what do you think the display output would be in this scenario? We have a nested list as an object defined over there. We are using arrays as list. We have ABC added, array as list, the first one, and the second one is X, Y, Z. So when we apply that stream operation, what do you think the result will be? And I will invite you now to submit your answer. Now you can do that. All right, seems that we already have a winner with option C, but A, B, and D are also being selected. And we only have a few more seconds left. And time's almost up. So let's see which was the winner. From your point of view, C was the one highly voted over here. And that is indeed the correct answer. I'll also display it so that you can see it on your phones. So that subtle condition that I was mentioning about to pay attention to is using flat map. And when you use flat map to flatten a nested collection, it applies that mapping to transform each element to uppercase. So the expected result from those small letters would be a concatenated string with ABC and the rest of the letters all together. All right, this was a quick one. Let's see what is coming. And what is coming, and I hope you will find this exercise interesting, because it's, let's say, a Java puzzle that uses concurrency and a specific map. So we have over there a concurrent hash map, and two threads that are attempting to update it concurrently. Each thread is incrementing the value associated with every key in the map. So we have there from 0 to 999. And it is incrementing that value by using a value of 1 and also using the merge method. So your task now will be to determine what do you think the output of this program would be. So what do you think that the resulting sum of all those values in the map will be after both threads will complete their execution? And I hope you're now ready to submit your answer. So what do you think? We'll get 1,000, 2,000, 10,000, or 20,000? OK, we are in between B and D at this moment. Also, a couple of you selected A and C. OK, B. OK, B has the most numbers of votes. And B was indeed the correct answer. So those of you that selected this, you're right. Here, we should reflect carefully on the anatomicity of the merge operation. That was the tricky part over here. I used the merge method. And obviously, the behavior of concurrent hash map under concurrent updates. And the merge method takes three arguments. So first of all, we get the key. Second of all, we get the new value. And the third one will be the function that we want to apply if the key already exists. So in this case, if we look at the code, we are using integer sum, which means that if the key already exists, it will sum the existing value with the new value. And after submitting both tasks to the executor service, it shuts down the service and waits for both tasks to complete with await termination. That is what I have used over there. So finally, it will print the sum of all the values in the map, and that output will be 2,000. All right, hope you had some fun with this one. And now we will stay in the same area. And this time, we have an exercise dealing with atomic variables. And we have there an atomic integer and, again, some concurrent updates. And let's see, what do you think the output would be when we run this program? So we have there two threads. We start them, we join them, and at the end, we display a count.get. So it could be that we will get a final count of 2, of 1, a 0, or perhaps we get an error. Maybe somewhere in the code something is not written correctly. So what do you think the result would be in this case? And you can now submit your answer. So let's see. OK, some of you consider that something is wrong over here and we have an error. But most of you selected already answer A. And now let's reveal the correct answer, which was indeed A. So no, the code won't cause an error, compilation error, runtime error. No matter, we don't get an error. We get displayed output of final count of value 2. And this is because atomic integer allows thread-safe operations, such as increment and get, the one that I have used in my example over here. And in this code snippet, those two threads concurrently increment the count. And then the main thread waits for both of them to complete before printing the final count. So we will get 2, because both of them will be executed, and both of them will increment that value. So this is why we get a final count equal to 2 in this example, because both threads will successfully increment that atomic variable. All right, let's move away a bit from this area and look at something from a newer Java version. And we have here an example with some sealed classes. There is a lot of code over here, so I guess I should leave you some time to look at it. And I'll also try to provide some examples of what we have here. So we have sealed classes and nested sealed classes. We have a class shape. We have a class circle that extends shape and implements drawable, which is an interface. You have it on, I think, on the right side. We also have a rectangle class, which extends shape. And in the main method, we have an object of type shape, instantiated a shape circle of 5. And we are checking if shape is an instance of that drawable interface, in which case we call the draw method. Otherwise, shape is not drawable. So when we run this code, what do you think will happen? And there are 4 available options. Either we get a compilation error, so maybe something is not entirely correct in what I have written over here. Or perhaps we get on that else statement and display shape is not drawable. Or perhaps we get a runtime error, or maybe we don't get any output. So I will now trigger the possibility for you to submit your answer. Please do so. And let's see if you correctly identified what is happening over here. And answers are coming fast. We have compilation error, top, no output as a second option. And the right answer was indeed a compilation error. So those of you that submitted compilation error, you're totally right. That option with no output, I put it over there, but with that if statement, it would have been hard not to get on the else part. So that was misleading. Sorry for that. Let's see why do we get a compilation error. In this code, if we were to look at it again, shape is declared as seal classes. And it permits only circle and rectangle to extend it, if we were to look at the definition of it. Both circle and rectangle are nested seal classes. And additionally, that interface that I told you to look at, drawable, is declared as sealed and permits only circle and rectangle to implement it. So far, so good. In the main method, however, an instance of circle is created and checked if it's an instance of drawable, which leads to a compilation error, because the interface drawable is not permitted to be implemented outside of its permitted classes. This is the definition of seal classes and interfaces. So this is why we do get the compilation error. Right. And for the next exercise, we will stay in the same area of newer functionality. And we have here an example of records. Have you worked with them? OK, half of you, perfect. Then at least you should answer correctly to this one. For the others, think of immutability when you want to select an answer. So let's check this exercise that uses records. We have 2 point objects over there, and we want to compare them, first of all, by using equals, and second, by using the equality operator. They both have the same values, so we have those coordinates 3, 4, 3, 4 for both objects. And as mentioned, first of all, we compare them by using equals. Second, we compare them by using the equality operator. So what will we get when we run this code? And I will now trigger the possibility of you to select the answer. So you can do that now. Now, sorry. All right. C was selected very fast by most of you, but also all the others are being selected. So let's see. 2 more seconds, and time's up. All right, let's reveal the answer. And yes, most of you were correct. Well done. When we use equals, we get true. When we use the equality operator, we get false. Why? Well, I mentioned about records and also provided you an advice to think of immutability. So records are those that avoids all the boilerplate code that we would have written ourselves or had the ID generated for us when we were to create an immutable class. And in this example, the equals method is auto-generated. So it is being used to compare the content of the records components. So in this case, this is why it gets true, because it compares the content of those two objects, 2 point objects that we have. However, the equality operator compares object references, so not content. And in this case, it results in false because, well, point 1 and point 2 are two different instances in this case. All right, let's move forward. And here we have a very small exercise that makes use of list of. So here we have a list of 3 strings, 1, 2, and 3. And we simply try to add another one, a 4 string. If we were to run this code, what do you think we will get? So we have 3 strings. We are just trying to add another one. But will we get an unsupported operation exception? Or we will get that 4 that is being added, or an error, or perhaps none of the above? After all, I don't have any print statements over here. So what is the expected output in this case? And think of that list of that I mentioned. That's the tricky part. And be prepared to submit your answers. I will trigger it now. So let's see what do you think will happen. Do we get an exception, a 4, an error, or something else? And we have a few more seconds. OK, we are in between A and D. Either we get an exception or none of the above. And the right answer was the one that most of you selected. We will get unsupported operation exception. And that's because list of creates an immutable list, meaning that it cannot be modified after creation. So attempting to add that element, that 4 string that I have added over there, it will result in an unsupported operation exception. So most of you definitely worked with list of so far. All right, let's see. We will stay in the same area with streams. I do have plenty of exercises in this area. And this code snippet creates a stream from a list of integers, from 1 to 10 in this case, and uses 2 methods from the stream API, skip and limit. Have you worked with them so far? Have you ever? OK, so a couple of hands raised. Perfect. You should answer correctly. So let's see. What do you think this will do to that list that we have there, the list of numbers? Either we get 1, 2, 4, 5, or an array made of the numbers from 4 to 7, from 4 to 8, or from 5 to 8. And let's see what do you think. And you can now submit your answer. So between these 4 options, what would you choose? OK, most of you selected B already. And on the second place is option A. But the correct answer was indeed B. And let's see why. We had there skip and limit, 2 methods. Skip, with a parameter option equal to 3, removes the first 3 elements. So leaving us with that array from 4 to 10. We removed elements 1, 2, and 3. Afterwards, we came with limit with a parameter of 4. And this operation restricts the results to the next 4 elements. So we'll get 4, 5, 6, and 7. These are the first 4 elements. So this is why B was the select answer, after applying both skip and limit to that stream. OK. And once again, in case you missed those optimization challenges, we have one now, and again with concurrency, but this time with completable futures. I will also, once again, leave you some time to take a look at this code. Because the question would be, how would you improve it? So we have there 3 futures, all defined by using the CompletableFuture. We have 3 tasks, task 1, 2, and 3. At the end, we are using then combine to combine future 1 with future 2 with an argument of a sum. And then, once again, we are using then combine with future 3 and sum as a method. At the end, we have a final result variable. We call it by using result.join, and we try to display that integer value. Each of the tasks simply returns the number of that task from the name. So task 1 returns 1, task 2 returns 2, and task 3 returns 3. The code works. It works, it displays something, but it can be improved. And I provided there 4 possibilities of improving this code. First of all, option A is to replace then combine with all of. The second option will be to add an explicit executor to supply a sync. The third mentions that perhaps we can use then compose instead of then combine. And the last one would be to change join with a get, the join from the result.join. I'm referring to that line. So out of these 4 possibilities, and I want to remind you about the disclaimer from the beginning, definitely there are several ways to rewrite this code completely. But out of these 4 options, what do you think it fits the best in this specific example? And I hope you are ready, because I'm going to trigger the possibility of you to submit the answer. So you can do that now, please. And let's see what do you choose. And so far, all the options are being selected, mostly A and D. So either to replace then combine with all of, or to change join with a get. B and C had a few answers only. So let's see which one was the correct one. And between A and D, which one? How many of you consider that is A? And how many consider that is D? Okay, let's see. Those of you that raised the hands for option A, you're right. Option A is the correct one. We should replace then combine with all of. And let's go a bit through all of them, or at least with a focus on A and D, because this was the highly voted answers. Option A is correct because all of waits for all the futures to complete. And it offers a better performance than just chaining then combine, as you can see here on the slide. I'll also show you how it looks with all of in a second. So instead of just chaining then combine, as I have that two lines example here, we should use all of. Option D, the previous one that was selected as being on the second place, it says to change join with a get. Well, both methods are indeed used to retrieve the results for a CompletableFuture, but they differ in how they handle exceptions. So in this case of handling exceptions, join is preferred over a CompletableFuture because it throws unchecked exception directly. So in this scenario, it is not advisable to simply replace join with a get, making option A the correct one, or at least the one that fits better out of those 4 options. And if we were to rewrite the code with all of, we will get something like this. The only change was with that CompletableFuture result part. We now have all of, and it's simply a list of all the futures that we want to combine, instead of just chaining, then combine. All right, enough with this concurrency. Let's switch a bit to Lambda expression, because the next exercise uses Lambda expressions to demonstrate how to filter a list of words using multiple predicates. And let's look a bit at the code, because I wrote a lot over here. So we have a list of strings, words as variable. It's it is using list of with a couple of fruits. Afterwards, we try to apply the first predicate that will filter that array list by applying to be higher, the length to be higher than 5. Afterwards, the second one checks if the word starts with A. And we filter the words using that filter words method from above, which accepts a list of words and an array of predicates. And that filter words method, as we can see there, it checks each word against all predicates and adds it to the result list if it matches all of them. The code works, but we need to improve it. There are way too many lines over here just for my simple example. So, as possibilities to improve it, we can refactor filter words method to use the stream API and combine predicates using AND. B mentions that perhaps inline predicate combination in main should be a better approach. Option C, use filter words method as is without any modifications. So maybe this code needs that logic entirely how I wrote it over there. Option D mentions that we should replace predicate with custom functional interfaces for better performance. So out of these 4 options, what would you choose? And I will let you select an answer in a second. I need to click on next. So, what do you think the right answer is? Okay, answer A is already winning. And on the second place, with the same number of votes, we have B and D. Right, and the correct answer was indeed A. And that because we need to refactor the filter words method to use something newer from the stream API, and combining predicates using that AND method results definitely in a more concise and more readable code, and I will show you in a second. So it aligns, let's say, with the best practices for modern Java programming than the old-fashioned way of writing all the stuff. And if we were to go with this approach, the code entirely will transform in something like this. It looks way better. Don't you think so? Great. All right. Let's check the next exercise. And in the next exercise, we have a simple hash map with some insertion. So first of all, we are inserting a John Doe. The second one inserts a Jane Doe. And afterwards, once again, we are inserting John, but with a Smith this time. So if we want to preserve the original key value in this example, so without the third exception to interfere with our plans, how would you change this piece of code? And as an option over here, as options, I selected something like A, use putifAbsent method, B, to modify the map to use a linked hash map to preserve that insertion order, C, to keep it as it is, maybe it already deals to preserve original key value, so it works as I stated, or option D, to use a tree map with a custom comparator that will handle duplicate keys. So out of these 4 options, what do you think is the correct one? And it's time for you to select one specific answer. So what do you think is the correct one? And we are in between A and D, and also B has several answers already. So a few more seconds left, and time's up. The right answer was A, and 50% of you answered correctly. The other 50% are in between B and D. So let's focus on these ones. So option A is the correct one. putifAbsent exists in the API, and it is being used for this purpose that I mentioned, to ensure that the existing key value pairs are not overwritten if the key already exists in the map. So exactly what I mentioned that we want to achieve with that exercise. So this effectively prevents duplicate keys from being added, and it preserves the original key values. So if we were to add put if absent either on all 3 insertion calls or just on the last one, we will get the proper result. Option B, because this was also selected, option B mentions to modify the map to use a linked hash map to preserve the insertion order. Well, it does preserve the insertion order, but it doesn't impact nor address the issue of duplicate keys. So it will allow you to insert it, only that it will conserve the order of the insertion. And D, well, that mentions to use a tree map with a custom comparator to handle duplicate keys. Using a tree map with a custom comparator will help definitely in sorting, but it doesn't inherently solve the problem of handling duplicate keys. It's not its purpose. So option D is not correct one because it won't help you fix the duplicate issues. It will help you just with sorting operations. All right, we have just a few more exercises. I also added a slide over here to show you how to use that method, put if absent. I only added it to the last insertion, but it can be added to all of them. And now let's switch to virtual threads. And the following code uses traditional threads for concurrent execution. This code actually creates 1,000 traditional threads to run concurrent tasks. I don't have anything more to say on this specific piece of code, as it's just 4 or 5 lines of code. But the question is, how can we improve it? And we can think of what Project Loom introduces and how it can be beneficial for us to improve this specific piece of code. And among the options that you'll have to select, first of all, to use the new virtual thread per task executor method from the executors, either to use a CompletableFuture for asynchronous task, perhaps using a cached thread pool instead of a fixed thread pool may be beneficial in this case, or perhaps we can use fork join pool for parallel execution. So out of these 4 options, and thinking of Project Loom, what would you choose? And I will invite you now to submit your answer. So please do that. Okay, most of you selected A. D is on the 2nd place, and B and C only have a few votes. And let's see what the correct answer was. Correct answer was indeed the one that almost all of you selected. Well done. It's to use the new virtual thread per task executor method. It was introduced in Java 18, if I remember correctly. And it will automatically create a new virtual thread for each task submitted to it, so when it is needed. And because all of you selected, almost all of you selected this answer, let's quickly move to the next exercise. And this is the last one, because the time's almost up. And this example deals with random classes. Have you worked with them? Almost all of you, great. So in this specific code, we have a random class to generate random numbers. And the question is how it can be optimized. We have there a random object, and from 1 to 10, we just generate numbers. The first option is to use thread local random instead of that random class, to use splittable random instead of random, to use random generator factory, or to use secure random for better randomness. So out of these 4 options, let's see which one you will select, and you can submit your answer now. Okay, most of you selected the D already. Also option A and C, those 2 are equally voted. So splittable random is definitely not an option for you. And let's see which was the correct answer. So most of you selected secure random, but I'm afraid the correct answer was C. And that is to use a random generator factory to select a generator. So this was introduced in Java 17, and it allows selecting the best available random number generated for specific requirements. So this provides flexibility and better performance. The option that most of you selected, meaning to use secure random, well, indeed, this provides cryptographically secure random numbers, and it is suitable for security-sensitive applications, for example, the one that I'm currently working for, military software, but it generates slower than other random numbers generator. So it's not a good option in this specific case. And because time's up, this would be the final exercise. I would like to thank you all for your participation. I do hope that you had some fun with these exercises. And I will just quickly get to the leaderboard so that you can see the numbers of options that were selected correctly. And if you can give me one more second, you have the leadership board already on your phones. And I see that Julia had 17 out of 20. It is 20, sorry, because I had 20 exercises, but the maximum is 17. This is the number that we managed to do in this session. So once again, thank you very much for your assistance and active participation, and I hope that you had some fun with these exercises. Thank you.